Good morning to all. Am I audible? Okay then. So today we will discuss network theorems. That is, I will not discuss all theorems. I will discuss few theorems in today's session. So let us start with superposition theorem. So superposition theorem. So superposition theorem, it states that in a linear network containing more than one independent sources, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone. All the other independent sources being represented meanwhile by their respective internal resistances. Okay. So this is the statement of superposition theorem. I'll just explain it so that you will be able to understand better. Okay. So this is the statement actually. Later you can note it down. I will just show you an image. Yeah. So you can see this is this first circuit. If you observe in this first circuit, you just carefully observe this first circuit. I will just take the laser. In this first circuit, if you see, you can see R1, R2, R3 and R4. For this, 4 resistors are connected in some series parallel combination. And in this circuit, how many sources are there? 2 sources are there. This is one voltage source. This is current source. Okay. So, according to the statement, this is a linear network. There are more than one independent source. How many sources? 2 sources, isn't it? There are 2 sources in this circuit, so more than one source is there. So, when both sources are there in this circuit, you can consider any element R1, R2, R3 or R4. In any element, you just measure the current, okay? Or you can calculate. Theoretically, you just calculate the current. Practically, you can measure, of course. But theoretically, you can calculate the current in any element. So, let us assume I have considered resistance R4. In this R4, the current flowing is I4 when both sources, voltage source and current source, both sources are present. The current flowing through R4 is how much? I4. Now, what I am going to do is I am going to remove one of the sources. Okay. So first of all, I have decided to remove this current source. So whenever we want to remove the current source, okay, what we have to do is, okay, to verify superposition theorem, what we have to do is we have to open circuit it. Okay, you have to completely remove it. You just observe the second figure, this figure. So here you can see only voltage source is acting. That's what I have written here. Only voltage source is there. What about the current source here? Current source, it has been completely removed. Okay, it has been removed. What is left over? R1, R2, R3, R4 as it is. Whatever resistors were there already, we have drawn them as it is, and voltage source wherever it was placed earlier in the actual circuit, same voltage source is there, but the current source, it has been removed. It has been open circuited. So if you have current source, what you should do is, to verify superposition theorem, the current source should be open circuited. So when now how many sources are there in this given circuit? Only one source. Okay. So it's not the given circuit, but in this circuit, in this modified circuit, we can say I have removed the current source. Okay, I have removed this current source. When current source is removed, okay, what is left over? Only voltage source is there. This is our modified circuit. Okay. So now when only voltage source V is there, same current. Earlier, how much current was flowing when voltage source and current source was there in the circuit? I4 current was flowing. Now only voltage source is there. Same I4 current cannot flow in this R4 resistor. Okay. I am considering the same resistor R4 here. and I want to calculate the current flowing through this resistor theoretically, or you can measure the current flowing through this resistor practically also. Okay, so whatever current that is flowing through this R4, same current will not flow, because earlier there were both sources, voltage source and current source were there in the given circuit. Now only one source is there. Okay, only one source is there, so definitely the current flowing through R4 will change. So let us assume the current flowing through R4 only because of this voltage source is I4 dash. Okay, I4 dash is the I4 dash is the current flowing through R4. Now, okay, so someone has mentioned to turn on the webcam. So if I turn on the webcam, this whole image, it will be, some portion will be occupied on this, what is it, on this presentation. Okay, so for me, means I have to reduce these images which I am showing you here. For them sufficient space will not be there. Okay, at least this portion, some portion maybe, maybe here webcam will occupy, my pen is this portion. Okay, so because of the webcam I have to reduce the font size as well as this circuit sizes. That's why I won't turn on the webcam, because this is not, I don't have a whiteboard or blackboard, and using that blackboard I'm not teaching it, isn't it? Using PowerPoint presentation I'm teaching this class, so that's the reason I won't turn on the webcam. Okay, so for webcam we need some space here. So, okay, so which will cover some part of my images which I show here. Okay, so that's the reason. Webcam, what is the need of webcam when we are concentrating on the class, isn't it? Class is important. Okay, not seeing who is delivering the lecture, that person is of no importance, because this is to learn the concept. Okay, leave it. So now voltage source only is there, so because of that voltage source, current flowing through this resistor R4, let us assume it is I4 dash. So when both sources were there, voltage source as well as current source was there, so the current flowing through R4 was I4. Okay, so current flowing through R4 was I4, and now, okay, now let us go to the other case when only current source is there in the circuit. Okay, so in the first diagram, what were there? Voltage source was there. This is our source. Yeah, I can't write source, my cursor won't listen to me, so it's better I will not write. This was the voltage source, this was the current source. Okay, two sources were there. Now what I want only current source in the given circuit. Okay, I want only current source, I don't want the voltage source. Okay, so what we should do is, whenever we want to remove the voltage source to verify superposition theorem, what we have to do is, we have to short circuit the voltage source. Okay, you have to short circuit the voltage source. See here, what was there? Here voltage source was there, isn't it? Now what did I do? I just short circuited it. Okay, I have just short circuited the voltage source, and the current source, it is as it is. Okay, same diagram, you just observe carefully. Same diagram here, short circuit. Okay, voltage source is short circuit. So verify superposition theorem, we must open circuit the current source and short circuit the voltage source. So when only current source is present in the circuit, voltage source is short circuited. Now let us consider same resistor R4. Okay, same resistor R4. Okay, when only current source is present, what is the current in R4? That is I4 double dash. Okay, current in R4 is I4 double dash. So according to superposition theorem statement, it is mentioned that in a linear network containing more than one independent sources, the resultant current in any element, okay, any element. Which element did we consider here? R4. Okay, we have considered R4 is our element now. So the current flowing through any element is the algebraic sum of the currents that would be produced by each independent source acting alone. Okay, so what is it? I4 is equal to what? I4 is what? I4 is the current when both sources were present. What is I4 dash? I4 dash is the current when only voltage source was present. What is I4 double dash? It is the current when when only current source is present. Okay, only current source. This is when only voltage source, and this I4 is when both voltage source and current source, okay, both were present. So what is I4 is equal to? It is the algebraic sum of the currents that is flowing through the circuit when individual sources are present. Okay, so this is our superposition theorem. If anyone wants me to repeat, you just mention in the chat box. Okay, so I thought if I represent all images in the same circuit, so what do you have to do to verify superposition theorem? Simply, first of all, to verify superposition theorem, there should be more than one source in the given circuit. So you must check whether there are more than one sources in the given circuit. Okay, so if there are more than one sources in the given circuit, then you must check. Okay, then you must check what type of sources are there in the given circuit, whether all are voltage sources or all are current sources, depending on the type of the source. Okay, so here of course I have considered only two sources, voltage source and current source. There can be more than two sources, okay, and they can be all current sources or they can be all voltage sources. It might be the case. Okay, so individually you have to remove each source. Okay, either you have to short circuit if it is a voltage source, or you have to open circuit if it is a current source. And across any element, here I have considered this resistor R4. Across any element you can measure the current, and you can add all those current together. Okay, if you add all those current, that current will be equal to the current which is flowing in the same element when all sources were present. Okay, so I hope you have understood. If anyone wants me to repeat, you just mention in the chat box. Let us go back to the statement. If you want, you can note it down in your notes. Write down the statement in your notes. So as soon as you complete writing it down, you just mention in the chat box that you have completed. So did you complete? Nothing is mentioned in the chat box? Okay then. Now let us solve some numerical problems. Okay. So find the value of find the value of current flowing through the 8 ohms resistor by superposition theorem. That's what the question is. Okay, that's what the question is. So this is the circuit. So you people can write it down. Write down the question and just to copy the circuit. Write down the question and copy the circuit. Did you complete? So if you see here in this circuit, there is a voltage source of 4 volts, another voltage source of 6 volts. Okay, and there are some resistive elements, some around 1 2 3 4 5 5 resistors are there, which are connected in series parallel combination. Okay, so let us solve this numerical problem. So as I have already told you, what is our superposition theorem statement? Superposition theorem states that in a linear network containing more than one independent sources, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone, while other sources being represented by their respective internal resistances. So if voltage source is there, it must be replaced by the internal resistance. Zero internal resistance, of course. If any resistor is contained in series, you can say that it is the internal resistance of the voltage source, or sometimes, you know, with along with the voltage 4 volts, internal resistance value will also be mentioned. So if any internal resistance value is mentioned, you must, when you short circuit this voltage source, you must replace it with the resistance value. Okay, and current source must be replaced by infinite resistance, and usually voltage source must be replaced by zero internal resistance. Okay, so if it is not mentioned, see here, there is no resistance value mentioned here, only voltage is mentioned. So the internal resistance of this voltage source is 0. Okay, so I hope you have written. So okay, okay then. Now let us they have simply, what did they ask? They have asked to find the value of current flowing through 8 ohms resistor. Where is our 8 ohm resistor? This is our 8 ohms resistor. So we have to determine the current that is flowing through 8 ohms resistor by superposition theorem. So let us start step 1. So what we have to do? We have to short circuit one of the voltage sources. I have short circuited the, what is it? Another voltage source value is 6 volts. Okay, so I have short circuited 6 volts. So earlier there was 6 volts here. So what did I do here? I just short circuited this source. Okay, so I have short circuited it, and I want to determine the current flowing through 8 ohms resistor when only voltage source V1 is 4 volts voltage source is acting. Okay, only 4 volts voltage source is acting. So this side is short circuited. Okay, now one second. This image. Yeah, so here you can see this is our source, 4 volt source. This is 4 volt source. This is our positive terminal. This is our negative terminal. Okay, so current I amps flows into the circuit from this source. Current of I amperes flows into the circuits from this source. Okay, this current is further divided here into two parts. Let us assume current through 10 ohms is some I1 current, and further it divides here at this So again at this junction what will happen? Current will divide. So my cursor, it won't listen to me. Okay, now our aim is to determine current flowing through 8 ohms. So let us assume current flowing through 8 ohms when only 4 volts voltage source is present in the circuit is I dash. Okay, I dash is the current flowing through 8 ohms. Okay, so if I want to determine I dash, I should determine I1. If I want to determine I1, I should determine I. That is it. Okay, I want to determine I dash. So for that I have to determine I1. Because I1 is the current which is dividing here at this junction, isn't it? I1 current flows through 10 ohms, and after that what happens here? It divides into two parts. And if I want to determine I1, I should determine I, because I current flows through 5 ohms and it divides into two parts. Okay, so let us determine the currents. Okay, for that, first of all, okay, let us determine the equivalent resistance, okay, total resistance in the given circuit. Because what is I will erase all inks. Okay, what is I? I is the total current in the circuit. Why I is called total current in the circuit? Because I is the current that is coming out of the source, isn't it? What is I? I is the current that is coming out of the source. So it is the total current in the circuit which will divide again and again if parallel paths are there. If there is any junction is there, that current will divide into parts. Okay. The total current in the circuit because of this voltage source 4 volts is IA. Okay. So in order to determine, I know total voltage is in the circuit is 4 volts. Total current is I. What is total resistance? If I know total resistance, I can determine, okay, I'm sorry. Yeah, I can determine total current. Okay. So already resistors are there. I know the resistor values. So let us go to the opposite side of the source. This is my source, isn't it? 4 volts voltage source. What is the opposite side? This is the opposite side. This is the opposite side. And okay. Now let us consider this loop. This loop. How are these two elements? Here at this junction, what did I say? Current is dividing. Means 8 ohms and 12 ohms are in parallel. 8 ohms and 12 ohms are in parallel. Why? Because the current is dividing at this junction. Divided current flows through 12 ohms and 8 ohms. If divided current flows through any two elements, those two elements are said to be in parallel. So what is the parallel combination of 12 ohms and 8 ohms? It is 12 into 8 or 8 into 12. 12 into 8 or 8 into 12 divided by 12 plus 8. Okay. 12 into 8 by 12 plus 8. It is 4.8. You just check it in the calculator and mention in the chat box whether I am right or wrong. Okay, is this correct? Answer, is this answer correct? Please check it in the chat box. Check it using your calculator. Check it in your calculator and mention in the chat box. Someone calculate it. Calculate the equivalent resistance. Okay, how to know whether the elements are connected in series or parallel? How to know? I have already told you here that current I flows through 5 ohms and at this junction current will divide into two parts. Okay, current will divide into two parts. This current flows up to this junction, again it divides into two parts. So at this junction current is dividing and flowing. One portion is flowing through 12 ohms, one portion is flowing through 8 ohms. So 8 ohms and 12 ohms are in parallel. Okay, so both are in parallel. So what is the equivalent resistance? 12 into 8 by 12 plus 8. Can anyone give me the answer? Is 4.8 is correct? 12 into 8 by 12 plus 8. Okay, 12 ohms and 8 ohms are parallel. So equivalent resistance of this portion. Okay, of this portion. Okay, I can't draw this circle even. So what is it? 4.8 ohms. So you can replace these two resistors with a single resistor. Okay, 12 ohms and 8 ohms can be replaced by what now? By a single resistor. How much is the resistance value? Just now we have calculated. How much is it? 4.8. Okay, how much is it? It is 4.8 ohms. Okay, so instead of drawing 8 ohms, now these two elements, they must be removed. and they must be removed by a single resistor whose resistance value is 4.8 ohms. Okay, now you just observe this circuit. Okay, now observe this second circuit. In this circuit, if you observe, what is the current here? I1 current. Okay, so I1 current flows through 10 ohms. And here, what is there current dividing at this point? At this junction or node? No, current is not dividing. Same current flows through 4.8 ohms. I will just once again erase all links and see, I1 current flows through 10 ohms and its direction is changed. But same current will flow through 4.8 ohms. So current is not dividing here. Same current is flowing through 4.8 ohms. Okay, since same current is flowing through 4.8 ohms and 10 ohms, so I can say 10 ohms and 4.8 ohms, they are connected in series. Okay, in series connection, current will not divide. In series connection, current will not divide. Okay, in parallel connection, current divides. Okay, so since 10 ohms and 4.8 ohms are connected in series, so what is the equivalent resistance now? 10 ohms is connected in series with 4.8 ohms. Just now I told you. What is the equivalent resistance? 10 plus 4.8. Simply add the resistance values. What do you get? 14.8 ohms. Okay. You will get 14.8 ohms is the equivalent resistance. Okay. So now replace 10 ohms and 4.8 ohms with what? 14.8 ohms. Okay. Instead of drawing two resistors, okay, draw only one resistor whose value is 14.8 ohms. Okay. Now this is it. 14.8 ohms is the resistance value here. Now you just observe I current flows through 5 ohms, and what is happening here? It is flowing through 5 ohms and it is dividing here into two parts. So that means that, okay, it is dividing into two parts. That means that 15 ohms and 14.8 ohms. How are they connected? Can anyone mention? I don't know if anyone is carefully listening to this class or not. Okay, there are no responses at all. So 15 ohms and 14.8 ohms, how are they connected? They are connected in parallel. 15 ohms and 14.8 ohms, they both are connected in parallel. Okay, these two resistors are connected in parallel. Why? Because current is divided current flows through 15 ohms and 14.8 ohms. So 14 and 14.8 ohms are in parallel. So what is the equivalent resistance? 15 into 14.8 . 15 into 14.8 divided by 15 plus, divided by 15 plus 14.8 divided by 15 plus 14.8. This point I don't know whether it is visible. Okay, 15 plus 14.8. So 15 and 14.8 are connected in parallel. You just solve it. You will get 7.45 ohms. You just check the answer. Okay, you should have the calculator during this class because I am solving numerical problems here. So 7.45 ohms you will get. Okay, so instead of drawing 15 ohms, where is my cursor? I'll take the laser. Okay, instead of drawing 15 ohms and 14.8 ohms, okay, what you can do is, you can replace them by a single resistor whose resistance value is 7.45 ohms. Okay, just replace it with single resistor whose value is 7.45 ohms. So this is our source. Now instead of 15 and 14.8 ohms, what did we write? We have replaced it with a single resistor whose resistance value is 7.45 ohms. Now I current flows through 5 ohms and 7.45 ohms. So what I can say, 5 ohms and 7.45 ohms are in series. You can add those two resistances. So now what is I? I is equal to 4 divided by 4 is what? 4 is the voltage source value, V by R. Okay. V value is 4. R value is how much? Both the resistors are in series. So 5 plus 7.45. So what is the total current in this circuit? That is 0.32 amperes. Okay. Total current in this circuit is 0.32 amperes. You just note it down. As soon as you complete, you just mention whether you have completed or not. I'll give you a minute. Just complete it. So I hope you have completed. So this is the total current. Now we know the total current. Okay. So we know the total current. Let us take back the other circuit which was 14.8 ohms connected parallel to 15 ohms, which is already there in your notes. So you just take the other circuit to determine the I1 current. To determine the I1 current, so you just take this other circuit which is already there in your notes. See this circuit, previous circuit. You just take this circuit to determine I1. Okay, to determine I1, you take this circuit. That's I have redrawn the previous circuit here. Okay, so I have redrawn the previous circuit. So in this circuit, what is I1 by current division rule? By current, we can apply here current division rule. Okay. So here by current division rule, I have already mentioned here by current division rule. So if I want to determine I1, I1 is the current flowing through 14.8 ohms resistor, isn't it? So what is the total current I? So total current I, okay, total current I into, I will write here, total I1 is equal to I into, okay, I1 is equal to, I will write the formula here, I into opposite resistance. Okay, so what I want to determine I1 current. I1 current is flowing through 14.8. What is the opposite resistance of 14.8? Opposite resistance, okay, is 15. Opposite resistance is 15 divided by 15 plus opposite resistance plus self resistance. Self resistance means what? The resistance in which I1 current flows. I1 current flows through 14.8. So 14.8. Okay, what is I value? Just now we have calculated, it is 0.32. So 0.32 into 15 by 15 plus 14.8. This is it. This is the formula. So substitute all these values in the calculator. Okay. So and determine I1. I1 is 0.16 amperes. Okay. I1 is 0.16 amperes. So if you know I1, what can you determine? You can determine current flowing through 8 ohms resistor. Okay. So this is it. So just write it down, copy it down. You can mention the answers in the chat box. If you are calculating, you can mention the answers. So whoever is attending this session, please attend with a calculator and a notes. So if you are writing, it will be partially just stored in your brain. So if you are simply listening to the class without writing, then it won't be much use to you. Of course, you may be able to understand, but soon you will forget. If you are writing, it will help you to remember for a longer period. So I hope you have completed. So now let's go back to one more circuit. Okay. So is this your first circuit? I think so. After removing one of the sources, isn't it? When you removed the source, short circuited the other voltage source, this was the circuit. Okay. After short circuiting the voltage source of 6 volts, this was the circuit. This is the circuit. So which you have got. So go back to that circuit, take that circuit. Now apply current division rule. So you know I1 value now. You know I1 value. So what is I dash? So total current at this junction is how much? At this junction, how much is the total current? I1. So I dash is equal to what? I1. I dash is equal to, okay, it is equal to I1 into, what is I dash is flowing through 8 ohms. So what is the opposite resistor? 12 ohms. So opposite resistance. Opposite to that resistor is 12 ohms, because I want to determine current in 8 ohms. So opposite to that means parallel connected resistor to 8 ohms is 12. Opposite resistance by opposite resistance plus self resistance, in which I dash current flows, that is 8. That is 8. So I dash is equal to I1 into 12 by 12 plus 8. So I1 value is 0.16 into 12 by 12 plus 8. You just solve it, you will get I dash is equal to 0.096 amperes. Okay, what is I dash is equal to 0.096 amperes. You just complete it. So in this numerical problem, they didn't ask us to verify superposition theorem. They have simply asked us to determine current flowing through 8 ohms resistor when by superposition theorem. So simply now whatever currents that we have got, I dash we have got 0.096 amperes. Okay, of course we have to one more step 2 is left over. We have to short circuit the first voltage source and keeping second voltage source in the circuit, we have to solve this numerical problem. Okay, so I hope you have completed. I hope I have given sufficient time to write it down. Okay, I hope you have completed. I'm just changing the slide. Now let us go to step 2. Okay, let's go to step 2. When only 6 volt source is acting alone in the circuit. So 4 volts, what has happened to 4 volts? It has been short circuited. What has happened to the 4 volts? It is short circuited. Okay, this 4 volts voltage source is short circuited. Only 6 volts voltage source is there in the circuit. 6 volts voltage source is there in the circuit. Okay. So because of this 6 volts, let us assume I amperes of current flows into this circuit. So I amperes is the total current flowing into the circuit. This current, this I amperes current flows through 12 ohms. At this junction, what will happen? Okay, I'm sorry. So at this node, what will happen? Current will divide. Okay, current will divide. Okay, current will divide into 2 parts. So actually we do not worry about further division of current. Why? Because our aim is to determine current flowing through 8 ohms. That's it, isn't it? So already we have got a junction where current is already dividing, so no need to consider how much current is flowing the remaining elements. Okay, so forget about it. So let us assume the current flowing through the 8 ohms when only voltage source 6 volts is acting alone in the circuit is I double dash. Okay, how much is it? I double dash. Notations are always, you can assume I1, I2, I3. your wish, whatever you want. I have assumed I double dash current flows through this 8 ohms resistor when only 6 volts voltage source is acting alone in this circuit, when 4 volts voltage source is short circuited. Okay, when 4 volts voltage source is short circuited, when only 6 volts voltage source is acting in the circuit. Okay, I double dash current flows through 8 ohms. Now similar to the previous case, here also I am going to determine the equivalent resistance, because in this given circuit, what is the total voltage in this circuit? 6. No, it's not the given circuit, modified circuit. Okay, so by I'm habituated to say given circuit. It's not the given circuit. Okay, so in this circuit, the voltage source is 6 volts voltage source. Okay, it is a total voltage. I is the total current that will flow in the circuit. So if I know the total resistance in the circuit, I can determine I. If I am able to determine I can determine I double dash by current division rule. Okay, by current division rule, I can determine I double dash. Okay, so first of all, let us determine the equivalent resistance. To determine the equivalent resistance, this is our source, isn't it? This is our source. Go opposite to the source. So opposite to the source, what is there? There are two elements which are connected in parallel. What are those two elements? Okay, from the source, go opposite to the source and consider, just look at the elements that are available at the opposite side. What are the opposite elements? There are 5 ohms and 15 ohms connected in parallel. Okay, so 5 ohms and 15 ohms are connected in parallel. Let us determine the equivalent of that parallel combination. Equivalent of that parallel combination is 5 into 15 divided by 5 plus 15. 5 into 15 divided by 5 plus 15, what do you get? 3.75 ohms. I'm sorry. You will get 3.75 ohms. I am unable to write 3.75 ohms. I'll once again write this 3. Okay. So this is it. So the total resistance of this total resistance equal resistance of this parallel combination. 5 ohms and 15 ohms are connected in parallel. So the equal resistance of this parallel combination is 3.75 ohms. Okay. 3.75 ohms is the equivalent resistance of this parallel combination. Okay. Now replace this 5 ohms and this 15 ohms by a single resistor. This is our single resistor in the above circuit, in this circuit. Okay, in this circuit, replace it with a single resistor whose resistance value is 3.75 ohms. Okay, if you are calculating, if you have the calculator in your hand, you just solve it and you can mention the answers in the chat box. Okay, simply sitting in front of your system or mobile and simply watching the class, it's not of much use. Okay, you should also solve along with me. So it may be of some use to you people. So now write it down. Draw the circuits and just write it down and draw the modified circuit. Now this is our modified circuit. Okay, I will take the laser. This is our modified circuit. 6 volts, 12 ohms to 8 ohms and 10 ohms and 15 and 5 ohms, 15 and 5 ohms, their equivalent resistance is 3.75 ohms. 3.75 ohms, this is the resistor. Is just complete it. As soon as you complete, mention in the chat box. I hope you have completed. If you have not yet completed, you just mention in the chat box so that I will just keep it as. Now this is our circuit. So this is our circuit, isn't it? Now if you observe in this circuit, if current starts to flow from this positive terminal of your source, this is positive, negative, and that current will flow through 12 ohms resistor, and at this junction what is happening? At this junction what is happening? Current will divide. Okay, so current will divide into two parts. So this current which is flowing through 10 ohms, okay, this current which is flowing through 10 ohms, same current will flow through 3.75 ohms, isn't it? Same current will flow through 3.75 ohms. Same current will flow through 3.75 ohms. Okay, so whatever 10 ohms current flowing through 10 ohms, same current will flow through 3.75 ohms. That means 10 ohms and 3.75 ohms. This 10 ohms and 3.75 ohms. Since same current flows through these two are said to be connected in series. Okay, so 10 ohms and 10 ohms is in series with 3.75. So what is total resistance? Total resistance of series connected elements, how much? Total resistance of series connected elements is, simply you have to add the resistance values. 10 plus 3.75, that is 13.75 ohms. Okay, that is 13.75 ohms is the total resistance. Okay, so you just replace the 10 and 3.75 with a single resistor. You can replace 10 ohms and 3.75 ohms. That is in the previous slide. This 10 ohms, I will just erase it. Okay, so you can replace this 10 ohms and 3.75 ohms which are in series. You just add the resistance values. You just replace it with a single resistor whose value is how much? 13.75 ohms. So now this is our modified circuit. This is our modified circuit. Okay, this is our modified circuit. Now here if you observe from the source, this is our source. This is the positive terminal. This is our negative terminal. Okay, from the source current comes out. I amperes of current comes out of this positive terminal. Current flows through 12 ohms. And after coming here at this junction, what is happening? Current is dividing into two parts. Okay, current is dividing into two parts. So what is the current flowing through 8 ohms resistor? Current flowing through 8 ohms resistor. You can determine the current flowing through 8 ohm resistor. Here current is dividing means what? 8 ohms and 13.75 ohms are connected in parallel. Okay, 8 ohms and 13.75 ohms are connected in parallel. Okay. Okay. So before determining current flowing through 8 ohms resistor, why? Because if I want to determine I double dash, I must know I value. I have not yet determined the I value. So before going to determine current flowing through 8 ohms resistor, I will determine the total resistance in the circuit. So 8 ohms and 3.75 ohms, how are they? They are connected in parallel. So what is the parallel combination resistance? 8 into 3.75. Total equivalent resistance of parallel combination is 8 into 3.75 divided by 8 plus 3.75. Okay. So what is the equivalent resistance of 8 ohms and 3.75 ohms? Oh, I'm unable to write 8 here. It's okay, I will try. Eight into, that is 13.75 divided by 8 plus 13.75. 8 into 13.75 divided by, sorry, 8 plus 13.75. So what is the value? You just solve it, you will get 5.06 ohms. Okay, 8 into 13.75 divided by 8 plus 13.75. What do you get? You will get 5.06 ohms. So now replace 8 and 13.75, this 8 and 13.75, which is the parallel combination, with a single resistor, with a single resistor, okay, whose resistance value is how much? 5.06 ohms. Okay, so you just replace this 8 into 13.75 with a single resistor whose resistance value is 5.06. Now what is our circuit? This is our modified circuit, isn't it? Now from this positive terminal, positive and negative, from this positive terminal, I amperes of current flows 12 ohms. Same current will flow through 5.06 ohms. Okay, same current will flow through 5.06 ohms. Okay, same current flows through 5.06 ohms. So now what is the current? I value is equal to total voltage V divided by total resistance. What is total resistance? 12 and 5.06 are connected in series. So add 12 plus 5.06. Okay, 12 plus 5.06. Okay, so what do you get? I value you will get 0.35 amperes. 0.35 amperes. So we have got the I value now. Okay, now let us determine the I double dash current that is flowing through 8 ohms resistor. I double dash current, let us determine. Let us take the same circuit here. You just take back this circuit, redraw the circuit in the next slide. I have shown that. You just take the same circuit to determine I double dash, because here we already have the equivalent of the other parallel elements, resistive elements. Okay, so this is it. Next slide. See, I have taken the other circuit, that is equivalent resistance opposite to this resistor 8 ohms is 13.75. I want to determine I double dash. I know I value now. Okay, so by current division rule, so I double dash is equal to what? I into I. Sorry, I didn't write I. It's not looking like I. So what is I double dash is equal to? What is I double dash? Is equal to what? Total current I. Formula is total current I into in which resistor I double dash is there? In 8 ohms. What is the opposite resistance of 8 ohms? Parallel to 8 ohms is what? 13.75. So 13.75 opposite resistance 13.75 divided by 13.75 plus, I'm sorry, yeah, I'm writing right. Yeah, already it is formula is there on this slide. Okay, Okay, that is it. 13.75 by 13.75 plus 8. I will write this 5 properly. This is it. So what is this I value? I value, as just now we have calculated in the previous slide, that is 0.35. Oh yeah, I am unable to write this 5 properly. Anyhow, I will try my best. This is 5. So okay, 13.75 by 13.75 plus 8. What is I value? I value is 0.35. It is already there here, and this is the formula. Okay, and you solve it, you will get I double dash is equal to 0.22 amperes. Okay, 0.22 amperes is the I double dash value. So what was the I dash value? Can anyone mention? Earlier we have calculated I dash. How much was it? How much was it? Can anyone mention? I dash value. It was how much? 0.096. Okay. I double dashed, how much did we get? 0.22 amperes. So what is the, according to superposition theorem, simply you add these two currents, you will get the total current in this in that element when both sources were present. So they didn't ask us to verify superposition theorem, but I have decided to verify superposition theorem. That's why I have gone for step number 3. It is not asked in the question actually, but I'm doing extra. Okay, if they ask you to verify superposition theorem, then you can go for this. Since they have not asked, no need to solve. But I have I decided to verify superposition theorem. Okay, that's why no need to. I'll remove the bold. This equation is bold. Okay, so I decided to verify the superposition theorem here. So for that I am going for step 4. When both sources are there. Okay, when both sources are there. What both sources? One is 4 volt source, another is 6 volt source. This is 4 volt source and another one is 6 volt source. Okay, I have taken the question as it is, and if you observe carefully, there are total 3 loops. So actually I should not say loop. Okay, I should say 3 meshes are there. Mesh 1. Okay, so instead of loop, you people it's better to write mesh. Mesh 1. Okay, mesh 2, and don't write loop, mesh 2 and mesh 3. Earlier I don't know why I wrote loop, but it's better to write mesh 1, mesh 2 and mesh 3. Don't write loop, write mesh 1, mesh 2 and mesh 3. Okay, so draw this circuit. You just take a minute, draw this circuit. I have assumed loop currents here. I want to determine, or my aim did not change. I want to determine the current flowing through 8 ohms. Let us assume some I amperes of current flows through 8 ohms. Okay, some I amperes of current flows through 8 ohms. Okay, some 8 I amperes of current flows through 8 ohms when both sources are present in the circuits. I want to determine this I value. Okay, so you just take a minute, complete the circuit. As soon as you complete, mention in the chat box. I will just drink water. Okay then, I hope you have completed this circuit diagram. So let us see. Let us consider loop 1. I have mentioned here loop 1. I will write mesh 1. I don't want this loop. Let us consider mesh 1. I'll just change this circuit. Just wait a minute. Instead of mesh loops, I want to replace it with mesh. Okay, it's over. So that's it. Now let us consider loop 1 or mesh 1. So in mesh 1, if you observe, what are all the elements in mesh 1? This is a source, this is positive terminal, negative terminal. In this here also, this is positive terminal and this is negative terminal. Okay. So here you can see voltage source and one more element here is what? 5 ohms resistor and one more element 15 ohms resistor. Total 3 elements are there in mesh 1. One voltage source and 2 resistors. So apply KVL in mesh 1. Okay. So algebraic sum of source voltages must be equal to the algebraic sum of the voltage drops in the closed path. So with only one voltage source is that, so 4 is equal to 5, resistance 5. Okay, resistance 5. 5 into how much current? I1 current. This loop current I have assumed I1 current. Okay. So I didn't discuss about loop currents, isn't it? So let me discuss about the loop currents. Let us first of all discuss about the loop current. So this is our mesh 1, mesh 2 and mesh 3. Total 3 meshes are there. So I have assumed loop currents in each mesh. Okay, 1, 2, 3. Loop currents in each mesh. I have assumed loop currents. After that, I have given some direction to these loop currents. I1 current, I2 current, I3 currents. So if you observe, I1 current is in clockwise direction. I2 current is I have assumed in clockwise direction. I3 current I have assumed in anti-clockwise direction. So your wish, in whichever direction that you want your loop currents to be, you can assume either in clockwise or anti-clockwise direction. It doesn't matter. It's not going to affect much. Okay. So now apply by mesh analysis. Apply Kirchhoff's voltage law. Mesh analysis or Kirchhoff's voltage law, both are same. Actually, okay. So you are going to apply KVL in mesh analysis. That's it. To verify mesh analysis, or you are going to verify Kirchhoff's voltage law only, nothing else. So in mesh analysis, we will verify Kirchhoff's voltage law. That's it. Now apply KVL in mesh 1. In mesh 1, as I already told you, there is a voltage source, there is a resistor, and another resistor is there. So total 3 elements are there. So algebraic sum of source voltage must be equal to the algebraic sum of the voltage drops. So source voltage is 4 volts. This is plus terminal and minus terminal. Okay, here also. Where is the cursor? This is it. Plus terminal and, I'm sorry, plus minus. Okay, now, so 4 volts. So 5 ohms, what is the voltage drop across 5 ohms resistor? Voltage drop is 5 into I into R. Okay, R value is 5, I is I1. So 5 into I1. Okay, plus 15 ohms, if you observe, it is in between what? In between mesh 1 and mesh 2. 15 ohms resistor is in between mesh 1 and mesh 2. Okay, so since 15 ohms resistor is in between mesh 1 and mesh 2, both currents will flow through 15 ohms resistor. So let us see the current direction in mesh 1. It is downward. Current direction in mesh 1 besides to 15 ohms resistor is downwards. Okay. So where is my cursor? It is here. So it is downward. What about I2 current besides 15 ohms? It is upward. You just observe, this is upward direction. This is downward direction. So both are opposite to each other. Therefore, differential current will flow through 15 ohms resistor. So difference of these two currents, 15 into I1 minus I2. Okay, 15 into I1 minus I2. So just solve it. What do you get? 5 plus 15, 20 into I1 minus 15 I2. 4 is equal to what? 20 I1 minus 15 I2. If anyone have not understood, you just mention in the chat box. I will just once again repeat the explanation. So I hope you have completed. Now I'll just copy this image in the next slide. So now apply KVL in loop 2, in mesh 2. Even if you write loop, it doesn't much effect, but this is it. Now let us see applying KVL in mesh 2. Apply KVL in mesh 2. So in mesh 2, this is our mesh 2. Is there any voltage source in the mesh 2? No voltage source. Write 0 is equal to the algebraic sum of voltage drop. So how many passive elements are there? 15 ohms resistor, 10 ohms resistor and 8 ohms resistor. Total 3 resistors are there. Okay, so let us add the voltage drops across each resistor. So let us start with 15 ohm resistor. 15 ohm resistor voltage drop is what? 15 into differential currents. As I have already told you that current flowing through this 15 ohm resistor, if you observe, I1 current is downward and I2 current is upward. Both are opposite to each other. So difference of I2 and I1. Since we are in mesh 2, 15 into I2 minus I1 plus 10 ohms. In 10 ohms, how much current will flow? I2 current. That's it. So 10 into I2 plus the voltage drop across 8 ohms. What is 8 ohms is also in between two meshes. So you just observe the current directions. You just observe the current direction. I2 current is downward. What about I3 current? It is also downward besides to 8 ohms. Okay. Both I2 current, I3 current, both are downward. Okay. Both the currents are downward. Okay. So you have to, downward means both are in same direction. So 8 into I2 plus I3. 8 into I2 plus I3. Okay. So this is it. This is the equation. Okay. So this is it. You just expand it. Okay. 0 equal to 15 into I2 minus I1 plus 10 into I2 plus 8 into I2 plus I3. So what you get? If you expand it and simplify it, you will get 0 is equal to minus 15 I1 plus 33 I2 plus 8 I3. Similarly, consider mesh 3. Yeah, consider mesh 3. Apply KVL in mesh 3. In mesh 3, you can see there is a voltage source and 12 ohms resistor and 8 ohms resistor. Total 3 elements are there. So algebraic sum of source voltage. Only one source is there. 6 is equal to 8 into what? 8 ohms into 8 is in between two sources. I'm sorry. 8 is in between what? Two meshes, not sources. 8 ohms is in between two meshes and the current direction of both the meshes is same. Therefore, you have to add those two currents. So 8 into 8, I2 plus I3 or I3 plus I2, it doesn't matter. So 8 into I3 plus I2 plus 12 into this 12 into I3. That's it. You just expand it, you will get 6 is equal to 8 I2 plus 20 I3. Okay. So I have considered both the equation numbers same. So this equation number is 3. Okay. This is it. Now we have equation 1, 2 and 3. You just use a scientific calculator. In the scientific calculator, press mode. In that mode, when you press mode, you will get some numbers besides to them. What is their operation? What's the purpose of those numbers? It will be mentioned in the scientific calculator. And if you observe number 5, besides to number 5, EQN will be written in the scientific calculator. Press that and give all the terms. Okay, or give all the terms. Okay, so all the terms means where was your equation 1? So first of all, in that it will be that you just give the 20, just type 20. First of all, you type 20 and press equal to, then type minus 15, then type 4. Okay, then press equal to. After that, type minus 15, press equal to button in your scientific calculator. Next type 33. Okay, Of course, it's a 3 variable, isn't it? It's a 3 variable. I forgot about third variable. So plus here, what is I3 value here? Plus 0 into I3, isn't it? So there you just select three equations, three variable equation. Okay, three variable equation, and type 20, press equal to, then minus 15, then 0. Okay, since coefficient of I3 is what? 0 here. In this equation 1, I3 is not there. That means coefficient of I3 is 0. So that you have to do in your calculator. Okay, so similarly plus minus 15, press equal to, plus 33, press equal to in your scientific calculator, then again press 8 and press equal to, and then again press 0. Okay, for typing the last equation 3, type 0, because I1 coefficient is 0. I1 is not there in equation 3. So type 0. Okay, type 0, then press equal to, then type 8, then press equal to in your scientific calculator, again press 20 and press equal to, and again press 6, and at last you will get I1, I2 and I3 values one after another. Again you have to press, first of all I1 value will be displayed, after that you press equal to, then I2 value will be displayed, then after that press equal to in your scientific calculator, you will get I3 value at last. Okay, if you don't know, if you have any senior with you, you can ask them. They will with the calculator they will explain it to you. Okay, so using the scientific calculator you can determine I1, I2 and I3 values. Okay, I1, I2, I3 are called, what are those? They are the mesh currents. So what do we want? Did you complete writing this? Can anyone mention in the chat box? Okay, actually what is our aim? Our aim is to determine current flowing through 8 ohms. Okay, our aim is what? To determine current flowing through 8 ohms. Okay, so what is the current through 8 ohms? I2 plus I3 current. Add I2 plus I3, what is I value? I value is 0.31. Okay, no need to draw this circuit. No need to draw the circuit. You just write this equation. No need to draw the circuit again and again. No need to draw. In order to explain, I have mentioned here. I am showing you the circuit here. No need to draw. If you are writing, just write this line and write I is equal to I2 plus I3. I value is how much? 0.31. Don't draw the circuit. Just write this content. So how much is I value? 0.31. So what about superposition theorem? What about superposition theorem? What is superposition theorem? What did I say? I should be equal to, I'm pressing right button. Okay, I should be equal to what? What is I should be equal to I dash plus I double dash. What is I dash? 0.096. I double dash 0.22. Okay. What is I? If you add these two, what you will get? 0.316. What was my I value? 0.31. So what is I? 0.3. I'm sorry. I value is 0.31. What did you get by adding I dash and I double dash? 0.316. So which is approximately equal. Approximately equal. Hence superposition theorem is verified. Okay. Let us verify superposition theorem. Superposition is one word actually. So I hope you have understood superposition theorem. If anyone have not understood, you can mention in the chat box. Okay, I am trying my best in the simplest possible way as possible. I am trying to explain this concept. So even though if you are unable to understand, you just mention in the chat box. I will repeat the concept. Okay. So this is our next problem. I'll just remove this numbering. No need of numbering. This is our problem. I want to verify superposition theorem using dependent sources. You can write down the question and copy down the circuit. Okay. Now here, what did they ask? Use superposition theorem to find V naught. Okay. So where is V naught? They have asked us to determine. You have to find V naught using what? Using superposition theorem. So where is V naught? This is V naught. Okay. What is V naught? What does it mean? By looking at the circuit, what can we say? Here it is mentioned V naught. What does it mean? V naught is the voltage across 20 ohms. That is it. You must analyze it. Being an engineer, okay. So you must analyze it. So V naught is the voltage across 20 ohms resistor. That's it. Okay. So you can see two independent sources, 10 volts and 5 amperes. These are the two independent sources. Okay, 10 ohms, 10 volts and 5 amperes are independent sources. There are some resistors, 5 ohms resistor, 20 ohm resistor and 10 ohms resistor are there. Two dependent sources are there. Okay, this is a current source, arrow mark is there, plus minus is there in this diamond shape. This is a voltage source. So two dependent sources are there. This is one dependent source. This is one dependent source. This is one independent source. This is one independent source. Two independent sources and two dependent sources are there. Okay. And what is our aim? We have to determine voltage across 20 ohms, that is V naught. And by superposition theorem, we already know we have to once remove one source and later we have to remove the other sources when single sources are present in the circuit. Okay. Independent sources. Okay. Present in the circuit, so you have to determine the voltage or current. Actually, earlier we have solved the circuit with current to for determining the current. Now we will solve the circuit to determine the voltage, which has dependent sources in it. So step 1. Voltage. Okay, here we are considering only voltage source, independent voltage source acting in the circuit. Okay, that is 10 volts. So what we should do? We should open circuit or short circuit the current source. What did I do? Can anyone mention in the chat box? Did I open circuit the current source or short circuit the current source here? Did I open circuit the current source or short circuit the current source? What did I do? I have open circuited the current source. Only voltage source is acting in the circuit. So voltage source only is acting in the circuit. Current source is open circuited. Okay. So this is it, and this is the given. This is the circuit now. So here you can what I have made some modifications here. You see here I5 is mentioned, V0 is mentioned, some 0.5 V5 is mentioned, 2 I5 is mentioned, and V5 is mentioned. So instead of writing I5, what did I write? I5 dash, V0 dash, 0.4, 0.4 V5 dash, V5 dash, and 2 I5 dash. So, okay, yeah, open circuited. Someone has mentioned in the chat box open circuited. Yeah, it is open circuited. Okay. So here, what did I do? I just modified these terms. I'll just expand this circuit. You people can copy it down properly. So this circuit, I'm just expanding it in this solution circuit, step 1 circuit. So you people just copy it down properly. It's because you just observe here. What did I do? I just modified the currents. I5 became I5 dash, V0 became V0 dash, 0.4 V5 dash became, I'm sorry, 0.4 V5 became V5 dash, and V5 became V5 dash, and 2 I5 became 2 I5 dash. So copy it properly, just copy the circuit properly. Okay then, I hope you have copied. I'll just minimize this circuit. Okay, I'll just copy it in the other slide. Now, what is V5 dash? V5 dash is the voltage across 10 ohms resistor, isn't it? V5 dash is the voltage across 10 ohms resistor. Okay. So what is the current flowing through 10 ohms resistor? You just see, observe here carefully. What is the current flowing through this element? This terminal is not there at all. This terminal I have mentioned here, it is open, so it is not there. Even though it is existing, okay, this is not there. Just forget about this. It is not there. This is also not there. So what is this? This is a current source, isn't it? This is a current source, dependent current source, of course. It is a dependent current source. So what is the current in this current source? This is voltage or current? It's the current value. Okay, isn't it? This is current source. Current source, what will the value of current will be always current value, can it become voltage? It cannot become voltage. Here I have mentioned V5. It doesn't mean that it is voltage. So what is this current value? 0.4 V5 dash is the current value. This is nothing but current. This is nothing but some I value. Okay. dependent current value. Dependent source current value is how much? Current value is 0.4 V5 dash. So now this is my resistor in this circuit. Okay. This current source and this resistor, if you observe, this current source and this resistor, how are they connected? They are connected in series. Okay, they are connected in series. Why? Because it is open. Okay, it is open. So no current will flow here. Open means no current will flow. Okay, here. So whatever current source value is there, that is the current flowing through 10 ohms resistor. That is the current flowing through 10 ohms resistor. So what is the voltage across this 10 ohms? I into R. R value is how much? 10. What is I value? This is I value. So what is the voltage across 10 ohms? V5 dash. V5 dash is equal to R, and R. How much is the R across V5 dash? 10. Okay, 10. What is I value? I value is how much? This current source and this resistor both are in series. Okay, in series connection we know current will not divide, same current flows through all the elements. So current in this 10 ohms is how much? 0.4 V5 dash. Okay, is it clear or am I confusing? This is bit dependent sources numerical problems are bit complicated. Okay, so you should carefully listen. You should try to understand. Okay, you people should carefully listen and you should try to understand. So V5 dash is the voltage across 10 ohms. Once again I am repeating, V5 dash is the voltage across 10 ohms. So V5 dash is the voltage across 10 ohms. So what is the, how to calculate V5 dash? V5 dash is equal to 10 into I value. What is the current in 10 ohms? This current source and this 10 ohms resistor both are in series because this terminal is open. So whatever current is there in this dependence, same current will flow through this resistor. Okay, both are in series. So 10 into current value is how much? This dependent source current value is 0.4 V5 dash. So V5 dash is equal to 10 into 0.4 V5 dash. 10 into 0.4 means 4. V5 dash is equal to 4 V5 dash. Okay. So V5 dash is equal to 4 V5 dash. So both side V5 dash is there. So what is V5 dash value? It is 0. Okay, both side V5 dash is there. So what value do we get? We won't get any value at all. So V5 dash value is nothing but V5 dash will cancel. Therefore, what is V5 dash now? V5 dash is 0 value. That's it. I'm trying to just minimize this. Okay. So now V5 dash is 0. This product will become 0. Okay. So voltage is 0. Okay. Here voltage is 0. Okay. V5 dash is 0 value. So this current source is V5 dash is 0 means this current source is open now. Okay. So if you remove this dependent current source, if it is open, so this branch element, this is dependent voltage source. If it is open, this circuit is open, this element, no current will flow through this current, this voltage source. Okay, dependent voltage source. If no current is flowing through this dependent voltage source, no current flows. This is open. Okay, this is open. This is open means no current will flow through this resistor or to this dependent voltage source. So even though they are existing, it means that they are not existing. Okay, so what is left over now in the circuit? Only this part is left over. When dependent current source is open, what is left over? Okay, what is left over? 10 volts, 5 ohms and 20 ohms. This is what is left over. So now what is V0? You can go for voltage division rule. You can go for voltage division rule. Okay, you can go for voltage. I will just type it. If I write it is not at all convenient for me. I will just type it by voltage division rule. So by voltage division rule. So now apply voltage division. I'll just expand it. Where is it? This is it. So by voltage division rule, what is V naught dash? V naught dash is equal to total voltage. What is total voltage? 10. I will write that also I can write it. Okay, I will try to write with this pen. So V naught dash is equal to, I will write the formula here, total voltage. What is total voltage? 10 volts into self resistance. V naught dash is across which resistor? 20 ohms. So into self resistance, that is 20 divided by self resistance. So how much is 20 plus opposite resistance, means series resistance. These two 5 ohms and 20 ohms are connected in series. 20 plus 5. I couldn't write 5. Okay, so what is the formula for by voltage division rule? You just apply voltage division rule. So total voltage across a resistor when two elements are there, more than two elements can be connected in series here. So of course here two resistors 5 ohms and 20 ohms are connected in series here. Okay, 5 ohms and 20 ohms both are connected in series. So voltage across 20 ohms, that is V naught dash, is equal to 10 into self resistance, means voltage the resistors across which you want to determine the voltage, that resistance, that is 20 divided by 20 plus opposite resistance, that is series resistance, that is 5. Okay, so 20 divided by 20 plus 5, what do you get? 10 into 20 by 25, you just solve it, you will get 8 volts. So this was our step 1. Open circuit in the current source. We have determined V naught dash. Okay, V naught dash, we have got V naught dash. Okay, now let us proceed further. I hope you have completed this image. I don't know whether this image. It is not required here. I'll just delete it. I hope you have completed. Okay. Now let's go to step 2. Okay, now short circuit the voltage source. Here what I have done, there was a voltage source, isn't it? What did I do to that voltage source? I have short circuited. I have short circuited the voltage source. Okay, voltage source is short circuited. So this is our modified circuit. By short circuiting the voltage source, this is the modified circuit. So only current source is there. So when only current source is there, better to go for Kirchhoff's current law to simplify the circuit instead of going for Kirchhoff's voltage law. Okay, since current source is there, I have assumed some node voltages, notations, nodes here, Y node and Z node. Okay, I have assumed some nodes here. You can assume 1 and 2, node 1, node 2. Okay, it doesn't matter. No need to assume Y or Z. So, for your sake, I will assume node 1 and node 2. Okay, it's better. It's better to assume node 1, node 2. Okay, so this is it. So I have assumed node 1 and node 2 here since only current source is there. So I made some modifications. I thought it will be more easy for the BTech students to follow the class if they are listening to this class. Okay, so here node 1 and node 2. So now apply KCL, not KVL, KCL at node 1. So apply KCL at node 1. So this is our node 1. Okay, so you just observe at node 1 what are the currents that are available here. So this is our I5 double dash current. This is V0 double dash current. We have assumed all the terms double dash values. We have given double dash. Earlier we gave V dash, I dash. Okay, here I have written double dashes. You just observe. You just write it down. Okay, so you just write it down. So now see here already current source is there. Dependent current source. Its direction is towards the node. Okay, and other currents you wish you can assume either all currents entering the node or all the currents leaving the node. Here I have assumed a source current, of course dependent source current already direction is mentioned, we can't change the direction. Okay, so I have assumed, I have kept it as it is, and this current direction in this 20 ohms I have assumed current is leaving the node, and in 5 ohms I am assumed current is entering the node. Okay, the 5 ohms resistor is connected to node 1, 20 ohms resistor is connected to node 1, and this dependent current source, it is connected to node 1. Total 3 branches are connected to node 1. Okay, total 3 branches are connected to node 1. So here, so what are all the entering currents? Entering, these two are the entering currents, isn't it? This current and this current. I'll take the laser. So this is the entering current, this is the entering current, this is the leaving current. Okay, so if currents are if you assume entering currents positive, you must assume leaving currents negative. If you assume leaving currents positive, you must assume entering currents negative. It's your wish. If you assume one current positive, another current you must assume negative. So here what did I assume? Assumed here is I have assumed entering currents negative and leaving currents positive. So here it is ground, isn't it? So I hope you know ground means reference. So at the reference node, this is ground is connected to the reference node. Ground means not reference, but ground is connected to the reference node, and voltage at the reference node is always 0. Okay, voltage at the reference node is always 0. So now what is the current in this branch? Current is the entering current, isn't it? Current is the entering current. So what is the current in this branch? Current is entering. So 0 minus V1. V0 dash. Acha. Okay. So here if you observe, voltage across this resistor is V0 double dash. So the voltage at this node will be V0 double dash. I will write it down so that it will be more easy. So see here, V0 double dash is the voltage across 20 ohms. So you can write here, this node voltage is nothing but V0 double dash. Voltage at node 1 is what? V0 double dash. Okay, so 0 minus current in branch 5 ohms. I want to determine current in 5 ohms resistor. So what is the current in 5 ohms resistor? Okay, current in 5 ohms resistor is I is equal to V by R. What is I? So current direction is from 0 volts to current direction is like this. Current direction is like this. Okay, this is V0 double dash. Okay, so current travels like this from this reference node, let us assume. So voltage is 0. So what is the potential difference across 5 ohms resistor? 0 minus V0 double dash. Okay, this is 0. I didn't write here. No need to write 0. We already know. No need to write 0. We always won't write. So 0 minus V0 double dash is nothing but minus V0 double dash V by R. R value is how much? 5. Okay. So next. So what is the current in this 20 ohms resistor? In 20 ohms resistor, what is it? 0 minus, okay, 0 minus V0 double dash by 20. Okay, 0 minus V0 double dash by 20. So and So whatever direction that I have mentioned here, is somewhat different. So I will just end the show and these are leaving current. 0 minus this is 0 minus this, and all the currents either I should have assumed open or closed. I'm sorry. No, means either I have mentioned all the currents either in one direction or in opposite direction. Okay, whatever. 0 minus 0 minus V naught dash. I just erased the inks. So this is V naught dash, double dash, V naught. So these directions which I have assumed, they are not satisfying. They are not satisfying me, to be frank. Okay. So what I have assumed here is all the currents entering, but I have shown here opposite direction. To be frank, the equation that I wrote here, that's the reason why I am just speaking something else. Okay, so the reason that is, again, the cursor won't listen to me. So here I have assumed current to travel from reference to this. Of course, I have mentioned there downward, but the equation that I wrote here, it is just opposite to that. Okay, so what is it? So 0 minus V naught double dash by 5 ohms. Okay, next reference voltage 0 minus V naught double dash. This is V naught double dash by 20. Okay, okay, that is equal to the entering current. What is the other source current? Okay, source current is 0. Okay, 0 point, or I can say I can't write it in terms of this node reference voltage. Why? Because there is no reference here at all. Okay, it is the voltage V naught double dash, or here node voltage is how much? V5 double dash. See here voltage is V5 double dash, isn't it? So that is V5 double dash there. So you can, but it is, there is a source here. There is not a passive element. So we can't take the voltage difference by R. There is no R at all, isn't it? There is no R at all. There is a current source. So you have to write down the current source value directly. Okay, you have to write down, the eraser is not working properly. Okay, so no need to write this node voltage. If required for next equation, we may write. So since this is the current source, so 0 minus V naught double dash by 5 plus 0 minus V naught double dash by 20 plus 0.4 V naught double dash. We have assumed here all the currents entering the node here. Okay, that's the reason. That's it. Okay, even though I have mentioned arrow marks downward, but it is the upward direction I have considered the currents. Okay, so 0 minus V naught double dash becomes minus V naught double dash by 20. So here also minus V naught double dash by 5 plus 0.4 V5 double dash. Okay, that is it. Now you just simplify this circuit. Okay, now simplify this circuit. You will get 0.4 V naught double dash minus V naught double dash plus 8 V5 double dash is equal to 0. You further simplify, you just get minus 5 V naught double dash plus 8 V5 double dash equal to 0. That's our equation 1. So if you have completed, just mention in the chat box. So if only the thing is, only one thing in this circuit, even though this arrow mark is 0, but I have considered the equation that I wrote below are for all the currents entering the node. Okay, all the currents entering the node, not few currents. First, by looking at the circuit, I thought 2 currents entering, 1 current leaving. The directions were like that, but this equation was not satisfying that. So the equations that I already wrote, I wrote them earlier. So I already wrote were for all the currents entering the node. So this is it. You will get equation 1. Did you complete? Okay, so I hope you have completed. Now let us write down KCL at node 2. Now let us write in KCL at node 2. Here you can see at node 2 what are all the currents there, how many branches are there at node 2? This is one branch, this is one branch, this is one branch. So okay, so here if you see here 5 amps current, it is traveling towards the node. 0.4 Wi-Fi, actually it is leaving the node, and V5 dash double dash is leaving the node, and this current it's our wish, we can assume any current, okay, any direction actually. Okay, so actually both the sources are there here. Okay, both sources are there, both are current sources. One is dependent current source, another one is independent current source. Okay, so this is dependent current source, this is independent current source. Okay, simply algebraic sum of all the currents at a node equal to 0. That's what I have assumed. I didn't even consider the directions properly. Okay, so whatever direction that I am mentioning here, they are of no use. Okay, simply I have considered all the currents, the algebraic sum of all currents at the node equal to 0. So what is the algebraic sum of all currents at node 2? What is one of the source current 5? Okay, plus another source current, dependent source current 0.4 V5 double dash. Another source current is what? V5 double dash by 10. Okay, V5 double dash by 10, another current. It's not the source actually, resistor. Okay, V5 double dash by 10, that is our another current at this node 2. Okay, so just simplify, you will get the V5 double dash value, that is 10 volts. Okay, so here I didn't mention any currents, I didn't consider the direction of the currents. So I didn't consider the direction of the current, simply I have considered algebraic sum of all currents at the node equal to 0. That's what I have considered. So I have added all the currents at node 2. Okay, I have added all the currents at node 2 and I have simplified. I have got V5 double dash equal to 10 minus 10. Minus 10 volts. I didn't see it properly. So V5 double dash equal to minus 10 volts. So from what is our first equation? Equation 1 we have written some equation 1. What was our equation 1? Okay, equation 1 equation was, it was minus, I will just show you that equation 1. What was our equation 1? This is it. It is minus 5 V0 double dash plus 8 V5 double dash equal to 0. Now we got some value for V5 double dash. Okay, now substitute that value in the equation 1. Substitute V5 double dash in equation 1. Okay, so you will get V0 double dash. So V0 double dash value is how much? Minus 16 volts. V0 double dash is minus 16 volts. Now we got V0 double dash. We already calculated V0 dash. So you just add those two values. So V0 dash is 8. So by superposition theorem, we already know that when individual sources are there in the circuit, okay, when individual sources are there in the circuit, if you determine the current or voltage across any element, okay, if you determine the current or voltage across any element, then the algebraic sum of those currents or voltages must be equal to the voltage in the given circuit when all sources are present in the given circuit. Okay, so this is it. So few more minutes, I will conclude. So you just copy it down. I will give you a minute, and I will just I will just verify the superposition theorem for AC circuit also. It will take hardly 5 to 10 minutes, and I will conclude this topic. Okay, I hope you have completed. It is simple. If you have any confusion, you just go through your notes. If you have written it in your notes, you just go through it. Later you will be able to understand. If you have any doubts, you can mention in the comment section. I will clarify your doubts later. Okay, so let us consider one more numerical problem here. Determine the voltage across 2 plus J5 volts. Okay, where is it? 2 plus J5. Here there is a resistor and an inductor. 2 plus J5. Okay. Oh, I have written volts. It's wrong. It's wrong. It is ohms, not volts. So I think so while saving, it happens when you copy it from one means when you download it from when you copy and save it at somewhere, and when you download it in some other place, some terms notations just change, okay, automatically. So we have to check that. I didn't check it. So determine the voltage, okay, across 2 plus j5 ohms impedance. So this is our impedance, okay, this is the impedance across which, oh no, this is the impedance across which I have to determine the voltage, okay, by using superposition theorem. So I have to use superposition theorem to determine the voltage across 2 plus j5 ohms, okay. So you just copy the circuit, write the question. Okay, so if you see here, there are two sources, one voltage source and one current source, and one inductor, one capacitor, and a resistor and an inductor connected in series, and we have to determine the voltage across this series combination of resistor and inductor. Now let us remove one of the source. Step 1. I didn't write step 1. Okay, so open circuiting the current source. I will just expand this. So this is it. Current source is open circuited. This is open circuited, current source is open circuited here. So this is the leftover circuit. Since current source is open circuited, in this capacitor current will not flow. Okay, current will not flow through this capacitor. Why? Because this terminal is open. This terminal is open, so current will not flow. So this is our voltage source. Okay, so what are these three elements? Now they are connected in series, so you can determine the current flowing through these elements easily. Okay, current flowing through these elements you can easily determine. So what is the current? I have notation, some notation I have given here, that is I1. I1 is the notation that I have considered here for the current. Okay, so I1 is the current flowing through these elements. 4 ohms, this is inductance, J 4 ohms, 2 ohms and J 5 ohms. So these are the reactance values. So reactance values are already, instead of giving inductance values, they have given us reactance values. So it is more easier to simplify now. So what is current I1? I1 is equal to V. What is V? 50 at an angle of 0 divided by V by Z. What is Z now? This 2 plus, okay, 2 plus J4 plus reactance value, J4 plus J5. So you just solve it. Okay, J4 plus J5 is J9. So 50 at an angle of 2 plus J9. So using a scientific calculator, you can see here numerator is in polar form, denominator is in rectangular form. So in the scientific calculator, there will be an option to convert polar form to rectangular, rectangular to polar. So this is in rectangular form. Without calculator also you can convert. There are some formulas. So you can get those formulas from the Google. You can search in the Google. Okay. So convert this polar to rectangular to polar. So I have converted rectangular term to polar term using the scientific calculator. So I have got 2 plus J9 replaced by 9.11 at an angle of 77.47. Okay, now 50 divided by 9.22, you just do it in the calculator, you will get 5.42, and 0 minus, the angle should be subtracted while dividing the polar terms. So here 50 at an angle of 0 degree must be divided with 9.99 at an angle of, this is 77.47 degrees. Okay, so you just divide it. 50 divided with 9.22, you will get 5.42, and angle should be subtracted. 0 minus 77.47, you will get minus 77.47 amperes. Okay, now we have got the current I1 value. Now what is the voltage across this impedance? What is the voltage? I into Z. What is I value that you have got? 5.442 at an angle of 0.7745. I value is this. So I, this is I into what is Z? 2 plus J5. What is Z value here? 2 plus J5. So 2 plus J5 is the Z value. So now this whole term is in polar form. Okay. This term is in rectangular form. Okay. One term is in polar, one term is in rectangular form. Okay, you just convert this 2 plus J5 in polar form. Convert it into polar. Okay, convert it into polar. You just convert that into polar, and after that multiply. After converting and multiplying, okay, multiplying, what do you get? After converting, you will get already 5.42 is there. You will get the magnitude as 5.38. And angle you will get 68.19. So add the angles, multiply the magnitudes. Okay, add the angles and multiply the magnitudes. Okay, this you can do only using scientific calculator or manually also, if you know the formula you can do that. Okay, so you must have the basic knowledge of converting polar terms into rectangular terms into polar terms. Okay, so that knowledge if you have, then you can easily simplify. Okay. So this is it. So magnitudes must be multiplied. You will get 29.16. Magnitude, angles you must add. If you add minus 77.47 plus 68.19, you will get minus 9.28. Okay, so this is volts. Okay, this is volts. Voltage V1. What is V1? V1 is the voltage across 2 plus J5 ohms when only voltage source is present in the circuit. Okay, now let us determine the voltage across 2 plus J5 ohms when only current source is present in the circuit. So I am about to conclude this topic. Within 5 minutes I will conclude it. Okay, when only current source is present in the circuit. So I will just end this. Okay, now I have short circuited the voltage source. Only current source is present in the circuit. Okay, only current source is present in the circuit. I have short circuited the voltage source. So this is it. Okay, so because of this current source, current flowing through this resistor, this impedance 2 ohms plus j 5 ohms is I2 current flows through this impedance. Okay, only current source is present. So I can go for current division rule actually here. If you carefully observe, from this current source, current will flow through this capacitor and it will divide into two parts. So it's better to go for current division rule. Okay. I have copied something and I forgot to remove this. Okay. So this is it. Now I am going for current division rule. So this is my current source. So current is I2. That's what I have to determine. So current I2 I have to determine. Current I2 is equal to what? Total current in the circuit. That is current source value. So what is the current source value? 20 at an angle of 30 degree. So current source value is 20 at an angle of 30 degree into, this is the impedance, not resistance. This is the impedance across which I want to determine the current. So opposite to it, here current will divide, isn't it? Current will, so opposite to it is, see the current direction, current flows through this element like this. At this junction, what is happening? Current is dividing here. Current is dividing into two parts at this junction. So one portion flows through 2 plus j 5 ohms, another portion flows through 4 ohms, j 4 ohms. So I2 current is equal to what? 20 at an angle of 30 degrees. 30 degrees, that is the total current, into what is the opposite impedance of this impedance? Opposite is j 4 ohms, because current is dividing between these two branches. So j 4 divided by 2 plus j. Yeah, I have added it here. So 2 plus, I will write it here. So 20 at an angle of 30 degree is equal to, into J4 divided by J4 plus 2 plus J5. 2 plus J5. Okay, 2 plus J5. I could not write that 5 properly. J5. Okay, so J4 plus J5, how much? J9. Okay, that's what is here. 2 plus J9. J4 divided by 2 plus J9. Okay, so this is in polar form, this is in rectangular form, this is in rectangular form. So convert rectangular terms into polar terms. Okay, So just using scientific calculator you can do that. If you don't know how to do, you just in the Google you can search how to convert polar forms into rectangle forms using scientific calculator. In this scientific calculator it will be mentioned. Okay, so just convert J4 into polar form. You will get 4 at an angle of 90 degree. 2 plus J9 you just convert into polar, you will get 9.22 at an angle of 77.47 degrees. So now just multiply 20 into 4. Okay, 20 into 4 and add 30 and 90. 30 plus 90 you will get how much? 120. Isn't it? And now 20 into 4. Okay, whatever you will get, 20 into 4, how much? Can anyone mention the chat box? Okay, it's how much is it? It is 80. 80 divided by 9.22. You just do it. You will get 8.68. Okay, and 120 minus 77.47. 120 minus 77. It is there here. I didn't see. Okay. So you just divide the magnitude terms, multiply and divide. You will get 8.68 and just subtract the magnitude angles. 120 minus 77.47. You will get I2 value. What is I2? 8.68 at an angle of 42.53 degrees. Okay, this is it. This is the I2 current. Now you know I2 current. I will just erase all links. Now we have determined current. Now we can determine the voltage across this impedance. So voltage is I2 into impedance value. What is I2 value? V2 is equal to what? Voltage across that 2 plus J5. I2 value is 8.68 at an angle of 42.53 into impedance is 2 plus J5. Just convert 2 plus J5 into polar form. It is in rectangular form. This is in polar form. This term is in polar, this term is in rectangular. Convert polar into rectangular. What do you get? 8.68 into 2 plus J5 you will get 5.38 and angle you will get 68.19. So multiply the magnitudes and add the angles. You will get V2 equal to 46.69 at an angle of 110.72 degrees. Now what is the voltage across? Is 2 plus J5, V1 plus V2. V1 you have got something, V2 you have got something. So V1 value is 29.16 at an angle of minus 9.28. We have solved it. And V2 you will get 46.69 at an angle of 110.72. Now both are in polar. You just convert them into rectangular. If you convert them into rectangular, you will get 28.78 minus J 4.7 minus 16.52 plus J 43.67. Now add the real values and imaginary values separately. 28.78 minus 16.52 you will get 12.26 and minus 4.7 J plus 43.67 J. You just add them. Add them means of course you are subtracting them. You will get J 38.97 volts. Okay, it is in rectangular. You convert that into polar. You will get 40.85 at an angle of 72.53 degrees. This is the voltage across 2 plus J5 ohms by superposition theorem for the given circuit. Okay, so I have discussed one numerical problem with independent sources, another numerical problem with dependent sources, and another numerical problem with AC sources. Okay, so this is about superposition theorem. So if anyone have any comments or if any part was difficult for you to understand, you just mention in the chat box. You just mention in the chat box. If you want me to give any explanation regarding any part which was not understood by you, I'll just explain it to you later. Okay, if you mention in the chat box, I'll give you the explanation. You just write it down.